Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for 3.1.5. Our M&Ms here, we finally getting into our notes, the difference between independent and dependent variables. Stated succinctly, the independent variable is always the x variable, and the dependent variable is always the y variable when we are plotting using an x, like y equals 2x plus 5. Okay, so when we've got our equations in this form, a two variable situation, the x variable will be the independent variable and the y is the dependent, and the x always goes on the horizontal axis and the y always goes on the vertical axis. So in this situation, we're saying, and this is the way I try and explain it to students, is you have total control of what number you plug in for x, but y, the value of y, depends on what number you choose for x. That's why the y variable is the dependent variable. You're trying to see, when you plug in different numbers for x, what effect that has on the y. So if you think about the John's redwood tree situation, the height of the tree was the dependent variable. And what affected how tall the tree was? Well, x, which was the number of years. So you could choose how many years after it was planted, after how many years when you wanted to measure the height of the tree. But the height of the tree would depend on how many years after it was planted, how tall it was, right? So I didn't really word that very well, but whatever. I think you're getting the right idea, hopefully. The x variable affects the y variable, okay? And so that makes the x independent and the y dependent on whatever you choose for x. All right, so this situation, your horizontal axis is always the x, the y is the vertical, but in this particular situation, these are just generic rules and points that go into a table. So when you really start to understand the difference between a dependent and a independent variable is when it's embedded within some kind of a word problem, like the giant redwood trees and the number of years after they were planted, what is their height. In a generic situation like this, it's just an input and an output. So what you do here is you find a given point, like this point right here is where x is equal to 2 and y is equal to 5. So plug that in, that would be this point right there, and then you can plug in another one here where x is equal to -3, y is equal to 0, so you can plug that guy in right there, and then all in between, and eventually you start to realize, okay, there's a connection absolutely between each one of these points. Wherever you have an x, if you add 3 to it, you get the output for y. And so that becomes the rule that applies to this situation. Y is equal to x plus 3. And then you can go and you can check it for any of them. And you can say, oh yeah, it works where x was equal to 4, y was equal to 7, right? Yeah, it absolutely works for all of them. Each rule below, make an XY table, then graph and connect the points. Okay. And of course, you want to label. I don't think we've yet talked about what makes a graph a complete graph, but we'll get there eventually. Maybe we've talked about it. It just hasn't shown up in the M&Ms yet. As you can probably guess, I'm recording these videos sort of out of order of when I'm teaching the lessons. I can't really remember what the exact lesson today was or yesterday was, but I'm sure we'll get into that at some point. So here we can make up any values we want for x. So I just decided to do -2 all the way through +3. So you plug in each one of those numbers. -2 times -2 is 4, and 4 plus 7 is 11. -2 times -1 is 2, plus 7 is 9. -2 times 0 is 0, plus 7 is 7. And what you start to notice here is in each one of these situations, value for y goes down by 2. So remember when we were talking about patterns in nature, you can kind of figure out these points if you put them in order and figure out the pattern. And so once you plot the first couple, you start to realize, oh, every single point I go down 2 and 1 to the right, down 2 and 1 to the right, down 2 and 1 to the right, down 2 and 1 to the right. and you see it forms a straight line. So you connect those points and then label. I say label at least 3 of them, but I ended up labeling all of them. Okay, so when you make a complete graph, make sure that you plot at least 3 or 4 points and you label at least 3 of them to make it a complete graph. Here, when x was equal to 0, y was equal to 0. So this is an example of a proportional situation. When x is 1, y would be 11. When x is 2, y would be 22. When x is 3, y would be 33. And so you can plot these guys, but you could also go into the negatives and then label them. So this would be how this graph would look. Now, one thing you might notice is that your graph, depending on what your counting sequence is on your x or your y-axis, your graph may not look exactly like mine as far as the steepness of the line goes. But what you should notice is that wherever my points are labeled, you should have points in the same location on your graph, regardless of how you scaled your graph. So the ordered pairs will be the same, but the line might seem a little bit flatter or a little bit steeper, depending on how you decided to scale your y-axis. Oh, I don't want to go through all this. This looks horrible. So let's just go to the answer. I'm getting really tired of these, and I'm sure you are too. So for this one, by the time you did all the legal moves and you combined like terms, you got 0 on one side, -3 on the other, or maybe you decide to stop here once you realize that -4 is indeed greater than -7. So the graph on the left, or not the graph, the expression on the left actually has a greater value than the expression on the right. And here, same idea. Once you got to this point, you realize -5 is less than -2. No, less than -1, because the more negative it is, the less it is. So we can decide at this point that the right side is going to be greater than the left side. All right, I cannot stress enough how important it is every time we see problems like this where we're doing multiplication with fractions or mixed numbers, that you practice to make sure you're understanding how all of this works. In the case of problem A, I never recommend multiplying a fraction times a decimal number. So either change them both to decimals or change them both to fractions. But you don't want to change it to a decimal number that has a repeating decimal. That's not going to work. So in this case, you pretty much have to change all of these or keep them all as fractions, because you don't want to multiply decimal numbers that repeat. And this is repeating decimal, that's a repeating decimal, all of them except for this. Every single one of these that are highlighted in yellow would convert to a repeating decimal. So it's just not going to do you any good. So keep them as fractions and just multiply straight across and then simplify the fractions. Remember, the idea of simplifying the fraction is you're looking for the common factors, and 16 and 30 have 2 in common. So if you divide them by the top and the bottom by 2, that's how you get your 8/15. 12 and 21 have 3 in common. So when you divide the top and the bottom by 3, you get 4/7. These you divide by 2, and this actually ends up giving you the answer in simplest form. Now, you might have chosen to write this as 1 and 1/15. That would also be okay, either as an improper fraction in simplest form or as a mixed number. I honestly don't care. And then the last 2 problems, being able to solve the equations. Take a look at my work. Here, I would collect my x's on the left side, so I would collect my number on the right, and then divide at the end to get x is equal to 2. And, it's always a good idea to check it to make sure that that is correct. So 2 times 2 is 4, and 4 minus 7 is -3. Here you get -2 times 2 is -4, and -4 plus 1 is -3. So yes, they balance out. That means we feel confident that is the correct answer. Sometimes a little bit harder to do the check. That's not that bad. 2 times 3.5 is 7, so that becomes -7 minus 5 is -7 plus a -5, which is -12. And on the right side, 3.5 times 4 ends up being -14, and -14 plus 2 is also equal to -12. So we can feel confident about writing our answer either as 3.5 or 7/2. Is that it? That is it. How much time did that take me? Oh, we're under 10 minutes. All right. So once again, if any of those problems I went too quickly, let me know. I will absolutely work those out for you. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. feeling blue.